I'll take a screenshot, but what is the problem is we don't initialize with theta naught. That's the only thing that we have need to. Otherwise, you'll get things confused. Because I'm just writing the equations of motion for linear motion, where your acceleration is constant, uniform acceleration. Now we'll go for rotational motion with uniform angular acceleration. Uniform angular acceleration. Because I'm just writing all in short forms. So what was the first equation? V is equal to u plus at. So that was linear velocity. Here you should have angular velocity. Omega is equal to omega naught plus alpha into t. So what is omega? Omega is final angular velocity. Okay. Omega naught is initial angular velocity. Alpha is angular acceleration. Theta is angular displacement. This is first equation. Second, you had S is equal to ut plus half at squared. So S was linear displacement. Here your angular displacement will be omega naught t plus half alpha t squared. Third one, it was v squared equal to u squared plus 2as. I can write this as omega squared is equal to omega naught squared plus 2 alpha theta. Is that clear, boys? (11b), is that clear for you all? 11b?
Yes, ma'am.
Yes, ma'am.
So now based on this, we'll solve numerical. By next week, we have to complete, I think within 3 days, we need to complete this chapter. Then we have to move for gravitation.
Theta is what once again?
Theta is angular displacement. I have written everything in short. ANG is angular, theta is displacement. See, when a body moves in a circular path, right, it sweeps an angle. Is that not? You think of your R and the seconds hand in your clock as the R hand or the seconds hand as it rotates, it sweeps an angle, right? Whenever a body moves in a circular path, should I redo circular motion? Or should I redo circular motion? Do you know what you mean by angular displacement? Once again, when a body moves in a circular path, right? So initially it might be, okay, right, you think of a string, one end of the string you are holding at point O, the other end of the string is tied to a mass, right? Now you're swinging the string with a stone tied to it. Initially, consider the stone is at point A. After some time, you are whirling it. Let it be in a vertical circle, let it be in a horizontal circle. After some time, your stone is going to reach the point B. Right? When the body starts from point A, reaches point B, it would have swept an angle. Right? The radius vector, which is your radius vector, OA is your radius vector. The radius vector sweeps an angle theta in a time of t seconds. When the body moves in a circular path, say the body starts from point A, goes to point B. When it's rotating about an axis passing through O, Then in a time of t seconds, it sweeps an angle. It has swept an angle theta, right? And what is your angular velocity? The amount of angle swept in a given time. If in a time of say 1 second, if the angle swept is greater, then the angular speed will also be of higher value. So that is what we call it as omega is angular velocity. It is the change in displacement divided by the time. To what extent of an angle it sweeps. So in a short period of time, if the radius vector sweeps a greater angle, then we can say the body is traveling with a greater angular or rotating with a greater angular speed. Shall we start with, have you completed this voice? Have you completed?
Yes, ma'am.
Okay. Now we'll start solving this numerical. Right. The angular speed of a motor wheel is increased from 1,200 rotations per minute to 3,120 rotations per minute in 16 seconds. What is its angular acceleration? Assuming the acceleration to be uniform, how many revolutions does the engine make during this time? Now, what is being given, boys? Angular speed of the motor wheel is increased from 1,200 rotations per minute. Please understand your angular speed omega is measured in radians per second. Now what is being given is in rotations per minute, which means it is angular frequency. Linear frequency, you have to convert it to angular frequency. What they have given is the number of revolutions made in 1 minute. So that you have to convert it to radians per second. So it's given as 1,200 RPM, that per minute you have to convert it to seconds. So divided by 60 RPS, rotations per second. So what is that? So nu is equal to, this is initial frequency, 20 rotations per second, that you have to convert it to. So omega is equal to 2 pi nu. Yes, boss?
I said to be multiplied by 2 pi.
Yeah, correct. So omega is equal to 2 pi nu. Therefore, omega naught will be 2 pi into 20 radians per second. So be careful whenever they specify 1,200 rotations per minute, RPM or RPS, which means it indicates frequency nu. That you have to convert it to angular frequency, or what we call it as angular velocity. Is that clear, boys? This is the first part of the question. The relation, this relation in circular motion, you have to understand this relation. Next. Yes, ma'am. All remote learning. What happened? Wait, ma'am. Any extra students have joined? Yeah, they're absent today. Okay, 1 second. So you want me to ask why the students have not come? Okay. Abel, then Jopal, Abel.
Yes, ma'am.
Abel, you are coming for blended learning for 2 days, or?
Ma'am, I opted for 2 days, but this week I couldn't attend, so I'll be attending from next week onwards.
Okay, fine. He'll be coming next week onwards. Okay, make sure. Okay, ma'am.
Okay,
Just he has to. Joe Paul.
Yes, ma'am.
So you have opted for blended learning for 2 days, right, Joe Paul?
Yeah, yes, ma'am.
Okay. SGS, correct?
Yes, ma'am.
SGS.
Yes, ma'am.
Okay. Then Steve. Yeah,
Yes, ma'am. Yeah,
Steve.
I opted for 2 days. STS.
All of them
SGS.
opted 2 days.
2 days for with SGS, correct, boys?
Yes, ma'am. Except for Able. Able is on
yes,
transport.
ma'am, on transport.
Okay. Thank you. Yeah, Able is on transport. Jopal and Steve are SGS, ma'am.
Ma'am, Zuhair as well.
Zuhair.
Zuhair is also.
Zuhair.
Yes.
Zuhair is in 11. Zuhair.
Zuhair, like he's also taken 2 days blended learning.
Yes, ma'am. 2 days with co-transport.
He is absent today. Sorry, 1 second. 34. One student is absent.
Ma'am, that's Muzammil, ma'am.
Muzammil is absent. Where is Zuhair? Microphone is not working. Zuhair. Class teacher Girja, ma'am.
Ma'am is trying to speak.
1 second, ma'am. Zuhair, is your microphone not working, Zuhair? Zuhair? Wait, ma'am. Someone has messaged. Let me see. Yeah, his microphone is not working. 2 days blended learning, ma'am. School transport, yes, ma'am. Thank you. Fine, boys. I'm just. Boys, you can go for Omega naught. We have completed. What about Omega? Because this is initial angular frequency. What is your final angular frequency? 3120 rotations per minute. Can you convert it to rotations per second and then find omega? Boys, can you do this? See, this is final angular velocity.
We can leave it in terms of pi.
2 pi itself, yes, no problem. Later on, we can let us check.
The SI unit is rad per radians per second.
Rad per second.
Actually?
Yeah, radians per second.
Okay.
Did anyone get?
Yes,
sorry?
ma'am. It's 2 pi into 52 radians per second.
It is
2 pi into 52.
Okay, just get me a number and then in terms of pi.
So that's 104 pi, right?
104 pi
104
radians.
pi.
Okay, 104 pi radians per second. Okay, so this is your final angular velocity. This is your final angular velocity, and omega naught. What was the value of omega naught? That was initial angular velocity. What was the value we obtained, boys?
40 pi radian per second.
40 or 45, boys?
40.
Okay, 40 radians per second. Fine. Now I have to go for angular acceleration. Okay, what is acceleration? Generally, acceleration is final velocity minus initial velocity by time. This is angular acceleration. So alpha is equal to final angular velocity minus initial angular velocity by time. Your time is 16 seconds. So alpha becomes equal to 104 pi minus 40 pi divided by 16. Can you find the value?
Ma'am, in the last, should we substitute the value of pi?
Yeah, you can. No, I think they have kept it fine. 1 second, boys, you can. They have kept it as it is, pi itself.
Ma'am, if we were to get alpha's value as negative, does that mean the rotation is in an opposite anti-clockwise
Yes.
direction or clockwise?
When the body comes to a stop.
No, ma'am, as
When the
like
body
the direction of rotation, ma'am, when it goes anti-clockwise, is it negative acceleration, or when it goes clockwise, is it negative?
it's not that direction is not taken into consideration as such. What we can do is that only if the body initially was rotating at a faster rate, finally its speed decreases. In that case, it can be taken as negative. Or if you go for sign convention, right? If you take if the body is rotating in clockwise, all other components, physical parameters are taken to be positive. In that case, you can go for it. Otherwise, the direction of rotation as of now, it's not going to make a difference. It's only whether the body is increasing its speed or decreasing its speed. So your alpha can be positive or negative. It's not that you cannot take negative if it is rotating anti-clockwise. It's not necessary. When you go for still more higher learning, where the convention is important. Like in optics, you have sign convention. Light is traveling. If you measure in a direction opposite to the direction of light, you take it as negative. So that is up to us to check which might be the direction of which direction should be taken as positive, which one should be taken as negative. Right now, we are not considering that. We are only considering whether the speed is increasing or decreasing. So the first part is over, boys. Now, how many revolutions does the engine make during this time? How many revolutions? Boys, the body is rotating. So for one complete rotation, what should be the angle? What should be the angle swept? For one complete rotation. Now look at this. 2 pi radians, yes. So one complete rotation, your angle swept should be equal to 2 pi radians. Now look at this. How many revolutions does the engine make during this time? Which
Two
means,
complete revolutions.
okay, fine. So you have to start with, you find the angular displacement. Now what is this? This is the angular displacement in time t seconds. The time is given as 16 seconds. You find your angular displacement. So number of revolutions will be angular displacement divided by the angle displaced, sorry, for one complete revolution. If the body starts from here, goes in this way, comes back to A. So one complete revolution, angle swept in, angular displacement in one complete revolution. So what number of revolutions, angular displacement in how many seconds, boys? In 16 seconds? Divided by angular displacement one complete revolution. In one complete revolution, what will be the angle swept? 360 degrees, right? In one complete revolution, angle swept will be 360 degrees, or like in terms of radius, 2 pi radians. But boys, are you clear?
Yes,
Boys,
ma'am.
are you clear? Right? So angular displacement in 16 seconds divided by angular displacement in one complete revolution. So when a body completes one full revolution, the angle swept, this is the angle swept, is 360 degrees in one complete revolution. Angle swept will be 360 degrees, or in terms of radians, it is 2 pi radians. That is why you get 2 pi in the denominator. Shall we move on, boys? Or have you completed? 11B.
Yes, ma'am.
Shall I go for the next one? Kritya. Kavin. Maheshwar.
Oh, yes, ma'am.
Abhishek. Boys, have you completed?
Oh, no, ma'am. Just give us a minute. I'm almost done.
Samuel, your paper, I have corrected it together, right? Both 30 and 50 together, I have given you the marks. Samuel? Is Samuel here?
Ma'am?
Samuel, I have given your marks for.
Ma'am, this is Prasanna.
Okay, Prasanna. What happened, Prasanna? Boys, I have rechecked all your papers once again. Right? I have given all your marks. Should I read out your marks? I have posted the file in your physics file section.
All right, ma'am. We'll check it there.
Yes, I have posted back. You haven't checked, or should I read out all your marks now?
No, ma'am. It's fine. We'll check
Out of
later.
30? Out of 30? Yeah, I don't think so. It's bad marks for me.
Yes, ma'am. Yes, ma'am. Do it.
Aaron 26, I'm talking about 30 out of 30, right? Only your MCQ is making a difference. Okay. Aaron 26, Abel 27, Abhishek 24, Austin 27, Ayan 26, Derek 29, Dheeraj 27, Fadil 25. I'm talking about section C, right, out of 30. Farhan 24, Harish 28, Hitesh 24, Jatin 25, then Johan 27, Jonathan 27, Jopal 26, Kavin 26, Kritya 27, Maheshwar 27, 26.5, 27, Nabil 26.5, so 0.5 will be taken as whole number. Taisir 29, Danish 26, Muzamil 24, Prasanna 26, Rishit 26, Samuel 20. Sorry. This is all your practical. Sorry, boys. I'm talking all about your practical. Sorry. I'm talking about practical marks. Sanford 27.
Practical.
This is all your practicals. Practical in that sense, you have 2 practicals plus MCQ plus your holiday homework.
26.5, not 26.
Who is that?
Mayan.
See, it really wouldn't matter, but ma'am, I think since all of us got our marks.
Yeah. So practical is not a problem, boys. Problem is your theory out of 30 I'll read out theory what I have corrected, and some of you have not corrected and given me out of 20 for them. I myself have corrected. Right? So Aaron 25 out of 30. This is I'm talking about theory. Abel 29, Abhishek 20, Austin 23, Ayan 27, Derek 18, Dheeraj 20, Fadil 19, Farhan. Long back I've sent you a file. Harish 27, Hitesh 24. If you don't want me to read, boys, I have already posted in your file section yesterday itself. Just check. If you don't want me to read out all your marks.
Yes,
practical
ma'am,
is fine. Okay, just check. Fine, boys. I'll go for the next one. Just check, boys, once again. You go for the next numerical. I don't know where it. Okay. So this is a textbook numerical. You need not copy down the numerical. Now look at this. A cord of negligible mass is wound around the rim of a wheel of mass 20 kilogram and radius 20 centimeter. Do you understand?
Ma'am, where are the
Yes.
marks, like the final marks?
I have
Ma'am,
put
I
this
can
in
see
your physics
practical
file
marks.
section. Practical marks I have added, but I have only entered your marks. That column I'm having separately with me, but all your marks I have put in file section. Can you see that?
Ma'am, it's not there.
Ma'am, it's
It's
not
not
there.
there, ma'am.
Physics file, Excel file. It's an Excel file. It would have been written as bracket practical. It's not only practical. I have put theory also.
Hello, ma'am.
Yes,
Yes,
ma'am.
ma'am, the file is there.
Hello.
Yes. What
What's the
happened? Was?
file's name?
I think so.
PDF
11B physics brackets.
practical.
It is an Excel file.
Yes, ma'am. Ma'am,
Yeah.
ma'am,
What happened?
wasn't there a lot of issues with the practical MCQ paper? And you said you will like check it.
I have changed. Yes, boys. I have changed the marks. I have
Ma'am,
changed the marks.
I think
But still, there were some cases where I have your practical marks were slightly different. But I have that one question was having two different options. So I have changed over there.
Ma'am, it's in physics file section 11B.
Yeah.
Ma'am, which one? Like in general or physics folder?
Physics only was.
Ma'am, were you able to change the MCQ to show us the answers?
Yeah, someone was asking me that because what I have done is I have just shifted. There were two options. One is to show students work. The other one is to give a comment. When if I am going for the comment, it would take a long time for you to check your marks. So I have just clicked students work. So since I have clicked students work, written to student, you can only see the marks. Or else if I would have chosen the other option, it would take a long time for each student. So if anyone who is really interested, if you want, then I'll take the screenshot and I'll put, if you want to see where you people are going wrong in your theory 20 marks MCQ. That's what someone was asking, right?
Yes, ma'am.
Ma'am, it's
Theory,
fine.
if you want, boys, the problem was, since you wanted to see the marks at the earliest, there were two options for me to click. One is return to the student. Immediately it returns to you. Or else I have to go for an option where I have to give comments for each and every answer. Only then it accepts. So for all
ma'am, I think you can return it, right?
response, it took
If
a
you
long
return
time.
it,
So
ma'am,
but from my side, from my point of view, I can see all your answers. So if you want to check where you are going wrong, then you just give me a message, boys. I will take a screenshot and I'll put it in your files. Those
ma'am,
who wants to check.
ma'am,
Yes, what happened?
ma'am, for that practical where that one question wasn't visible, right? Like for me, I didn't get
Yeah,
that.
I have adjusted your marks, boys. They're all over there. I have adjusted your marks.
Because
And yes, boys.
I had gotten
No,
the
what
same.
I've done is, no, I have adjusted the marks over there, wherever genuine things have to be there. And so what I've done is your project, I have given you, most of you have given you full marks. So that adjustment I have made in
Okay, I made it in the
project.
Okay.
Because there manually to change your marks was difficult. It was
In the
difficult.
Excel, it
I've
was
adjusted,
saved.
but only few students who submitted at the last moment, because I have to differentiate between students who have already submitted. Only for them, I think late submission only I have just 0.5 marks I have deducted. That's what whenever we say, please do submit, you have to submit it at the earliest voice. Now what is happening is 2 months before that some children are submitting, and after me calling you, you are submitting. There should be a difference, no? Those students promptly have done their work. Then last minute submission, right? This should not happen. That's what you, whenever the deadline is given, boys, you should meet the deadline. But anyway, I have deducted
Ma'am?
only 0.5 marks.
And for
What
the
happened?
section B, okay, the self-corrected for the
Yeah,
self-correction for the
self-correction
ones who
I
have
have
done,
sent
you have added
this
that
voice.
marks.
Yeah. For all those boys who have given me the self-corrected paper, I have gone through your paper. Only minor correction was there. That also not for all. Some minor correction, but some have not corrected and gave me the papers back. For
No,
them,
for the
I did the
sent it
self.
once, ma'am, you told me I didn't send, so I had to send it again to the same email.
No problem. If I have not received section B, I myself have corrected. Section B was what happened to section B is that in section B, those who have sent me the file with all the corrections, I have taken their marks. But those who haven't sent me section B or delayed it, I myself corrected and gave them marks. Okay. But still, I have sent all the section B files also to you. Yes or no? Yes.
Ma'am, for me, my section B marks ended with like 0.5, like 17.5. So will that be rounded?
Who is that? Taisir?
I say yes, ma'am.
Wait. 1 second, please. I'll just check. Taisir.
Ma'am, can we leave?
Yeah, 17.5. Yeah, you can leave, boys. 17.5 Taisir, I
Thank
had
you,
made it
ma'am.
as 80.
Okay, ma'am. Thank you, ma'am.
All 0.5s will be made as 18. Boys, wherever practical MCQ, because the paper was
Ma'am,
not
I
from me,
got
it
like,
was
in my one,
somewhere
I got
else.
19.5, so that will be rounded.
19 point. Who is that?
19 or
Just tell
something.
me.
When I had it corrected.
Dheeraj, is it Dheeraj?
No, ma'am,
Is that Dheeraj?
I guess 19 or 18 you gave me.
Muzamil, 1 second. Muzamil, you got 19. In some cases where you have sent your paper, I have made some small corrections, boys.
Okay, ma'am.
Some
So I got
small
19.
corrections. If I could have.
Ma'am, the marks for the practical MCQ, did you update that?
No, I have updated, and moreover, I have given those extra marks in your art integrated project. Only for late submission, I have reduced 1 mark, I believe.
Yeah.
For others,
Like
I have
she
given.
adjusted it with
Ma'am,
the
it's the
Yeah.
same, ma'am, for me.
Yeah, that's what she adjusted it project. Like there is something
Yeah,
called AEC
see,
project
no,
in the
MCQ was what has happened is in MCQ, I went through the MCQ. There were 2 options. In one of the cases, it was an open-ended question. For the open-ended question, I have given you marks. I've updated your marks. But somewhere you people had some difficulty. Wherever I can do justice for the MCQ, I've updated your marks. But still, you felt that it was some questions were not clear, so that I have updated in AAC. Okay. Is that fine, boys?
Ma'am, what is the AAC again?
That is your art integrated project.
Okay, ma'am.
Right?
Yes, ma'am.
The MCQs, certain questions were fine, but I think so you people have taken it. Only one question where the diagram was not clear, that I have updated. And boys, you can leave. But go through your paper, whatever being sent, please go through your paper. Next time, you people should not repeat those mistakes, boys. Okay?
Thank you, ma'am.
Thank you, boys. Thank you.
Thank you, ma'am.